is going to be the second chapter of Chapter 6, or second section of Chapter 6, which is going to be dealing with our first quadrilateral, which is parallelograms. So let's go ahead and get into it. So a parallelogram, remember, a quadrilateral is a four-sided shape. So it's a type of polygon. A parallelogram is a type of quadrilateral. It's the most basic type. It's kind of like the parent quadrilateral for most of the other quadrilaterals we'll talk about later. But it's kind of like, I guess the best way to describe it in layman's terms would be a slanted rectangle. So if you think of a rectangle and you kind of slant it, you get this sort of image, and that's a parallelogram, or what the typically people think of a parallelogram is. So these are the properties of a parallelogram. So I'm going to kind of diagram them out here. So opposite sides are parallel. So that means that these two lines are parallel. They will never intersect. And these two lines are parallel. They will never intersect. Okay? Opposite sides are congruent. So this length and this length are the same, and this length and this length are the same. Opposite angles are congruent. I should say angles, not angels. But that means that this angle here and this angle here are congruent, and this angle here and this angle here are congruent. Now, the first three properties are just like what you would have in a rectangle. That's because a rectangle is basically a special kind of parallelogram. So that's why it shares a lot of the same properties. In fact, number 4 is what actually makes a rectangle, and that is if one angle is a right angle, then all 4 angles are right angles. And that's what the definition of rectangle is basically a parallelogram with 4 right angles. And then the consecutive angles are supplementary. This is the one that most people forget. It basically means that if I take these two angles and add them together, those would add to 180. These two angles would add to 180. These two angles would add to 180. And these two angles will add to 180. So if you go side to side, the angles that you hit should add to 180. Or put another way, angles on the same line should add to 180 in a parallelogram. And then again, angles that are opposite of each other are going to be congruent, as it says right here. Okay? Now, number 1 is actually what we say defines a parallelogram, and that is opposite sides being parallel, thus the name parallelogram. And all the rest of these are properties that result from this fact. So if you make the opposite sides of a quadrilateral parallel, then you get these 4 properties that follows it. So that's why we call this one the defining characteristic of a parallelogram. Just a little bit of a tidbit of information there. So let's go ahead and use some of those properties to fill out a parallelogram here. So if we are given that this is a parallelogram, and it says find the missing sides and angles. Well, I know that opposite sides are congruent. So if this is 8 meters, that means that this bottom one also has to be 8 meters, even though it looks longer, but we'll see. If this is 11 meters, that means this one also has to be 11 meters. So opposite sides are congruent, and opposite angles are congruent. So if this angle right here is 85, that means the angle opposite it, that is also going to be 85. Now, what about the last two angles here? Well, these have to be supplementary to the angles that they're connected to, right? So this angle right here, angle D, has to be supplementary to this angle up here, which means it has to add to 180. So these two angles need to add to 180. So I'm going to make an equation. X, which is what angle D is, we'll say, plus 85 is equal to 180. And then we go ahead and solve this through. So minus 85, we get X is equal to 95. So that's 95 degrees there. And then again, opposite angles are congruent, so this has to be 95 as well. And that's a filled in parallelogram. So again, opposite sides are congruent, opposite angles are congruent, and then consecutive angles or side-by-side angles add to 180. Now, the diagonals of a parallelogram also have their own properties. So if you have a parallelogram, then the diagonals bisect each other. So that basically means that if I have a parallelogram, the diagonals cut each other in half. So this diagonal right here, oh god, it's a horrible diagonal. Let me try that again. So this diagonal right here and this diagonal right here are going to cut each other in half. So this segment is going to be the same length as this segment, and this segment will be the same length as this segment. So let's say like this one might be 5 and 5. This one might be, 16 and 16 or something like that. So the diagonals will cut each other in half. Not only that, but they also cut the parallelogram into two congruent triangles. So for instance, if I have a parallelogram, oh, okay, that's a little bit too horrible. Let me try that again. So if I have a parallelogram like this, there we go, a little bit better. That means that if I draw a diagonal, like let's say from here to there, that means that triangle 1 is going to be congruent to triangle 2. So these two triangles will be congruent. So again, opposite sides. So you have basically the SSS theorem there, right? So top triangle congruent to bottom triangle. And same holds true if I drew the diagonal the other way. But that's a property that comes up that really helps us out when we start doing proofs with parallelograms. Now, it's pretty easy to actually prove this second step here. So it's easy to prove that this is true for any parallelogram. So let's do that real quick. So let's prove that uh, statement there, that if a shape is a parallelogram, then diagonals cut it into two congruent triangles. So we have ABCD, it's a parallelogram. I want to prove that ABC, this triangle here, that's made from a diagonal cut, I want to prove that that triangle is congruent to DBC, which is this bottom triangle. I want to prove that these two triangles are congruent. So I'm going to use that as my given statement. So then, since this is a parallelogram, I know that opposite sides are congruent. So I know that AB is congruent to CD, and that AC is congruent to BD. How do I know these? Well, because opposite sides of a parallelogram. This is how I abbreviate parallelogram, as I draw the two lines to represent parallel and then just add in an O-gram there. So parallelogram, which is looking really bad there. Let me rewrite that. Let me try to write that a little bit nicer. So the reason I know this is opposite sides of a parallelogram are congruent. Okay? That's a property that we know that we actually talked about just a few minutes ago. So that was that property right here. Opposite sides, whoops, right here. Opposite sides of a parallelogram are congruent. So that means that opposite sides, boom, boom, and boom, boom, will be congruent. I also know that CB is congruent to CB because it is reflexive. Again, this is one of those freebie sides there, right? Reflexive. I'm not sure why I put a little symbol at the end there. So the reason I know CB is congruent to itself is because of the reflexive property. And again, the reason I wanted to write that down is because if you look here, both of these include the side BC. So I guess I should have said BC congruent to BC, but same deal. So if if I'm trying to prove that two shapes are congruent and I know that they share a side, I want to make sure that I label that side as congruent to itself because of reflexivity, which means that I can then use my SSS theorem, because if I know that this side's congruent to itself, well, now I have three sets of sides congruent to each other. So I know that triangle ABC is congruent to triangle DBC because of SSS. So this is one of those 4 or 5 triangle congruency theorems that we talked about last chapter, and that proves that these two triangles are congruent. And I can do the same theorem if I cut it the other way too. So technically, to be complete proof of this, I would have to do this theorem twice, once for CB and then once for AD for each diagonal. But you would apply the same reasonings just with different sides there. So the proof wouldn't really look any different. But this is how you prove properties of shape. So if you say a property has a certain shape, there should be proofs to go along with it. And some proofs are easier than others. So proving that a diagonal cuts a parallelogram into two congruent triangles is relatively simple with the tools that we have right now, or relatively straightforward, I should say. There are other properties that would take a little bit longer to prove that we're not going to go into right now. Now, we can also use these properties in algebra problems, which is kind of how we're going to start out most of this chapter. So if I want to solve for x in these problems here, so the first case, okay, solve for x. Well, the goal is to figure out how these two sides, or angles in some cases, relate to each other. And usually it's going to be one of two cases, or one of three cases. They're either going to equal each other, they're going to add to 90, or they're going to add to 180. So most of the time you have one of these three situations. Now, these two are only for angles, so angles only. So if you're trying to figure out what the relationship between two segments are, usually they're going to be equal to each other. Now, sometimes you might have to do a little bit of finagling to get them equal to each other, so it's not always going to be that case. There are some, fourth style weird cases that go on, but for the most part, if you're ever confused and you're trying to figure out what the relationship between two segments is in a quadrilateral, it usually is that they're equal to each other. And the reason that we know that these are equal to each other, that 2x plus 8 is equal to 3x plus 1, is because one of our properties is that the diagonals bisect each other. So the diagonals cut each other in half, which means that this diagonal right here, AD, is going to cut this diagonal right here, CB, in half. So this segment is going to be the same length as that segment. So then we can just solve this here. 2x minus 2x minus 1 minus 1, and we get 7 is equal to x. So again, diagonals cutting each other in half is going to be a property that we're going to use a lot in the algebra style of this section, so make sure that we don't forget that. The next one is dealing with angles. So again, angles are usually one of these three cases: equal to each other, add to 90, or add to 180. In this case, since these angles are consecutive, they're side by side, they're on the same line, we know that these two angles are going to add to 180, because that's the rule for a parallelogram. If we go back here, um, consecutive angles are supplementary. So angles that are side by side add to 180. So that's exactly what we have here. Side by side angles, they're going to add to 180. So 3x plus 32 plus 5x minus 12 is equal to 180. So I'm going to simplify the side first. So 3x and 5x make 8x. 32 minus 12 makes 20. Subtract 20, subtract 20, we get 8x is equal to 160. Divide by 8, and we get x is equal to 20. And that's our variable. Now, the last one here is a little bit tricky because it's not immediately obvious. The thing you have to remember on this one is that the opposite sides are parallel as well as congruent. So these two sides are parallel to each other. And if you have parallel lines, that means you have possibly interior or corresponding angles. So in this case, ABC and BCD, those angles there, if I follow this along here, they make, if you remember a few chapters back, they make that Z pattern. And we know that if we have a Z pattern involving parallel lines, that means that the corners of the Z are going to be alternate interior angles, and alternate interior angles are going to be equal to each other because they're going to be congruent. So this is a case where 5x plus 2 is going to be equal to 6x minus 4. And again, the reason being is because they're alternate interior. They form that zigzag or that Z shape. So be careful that when you see a diagonal in a parallelogram, do know that you have alternate interior angles at play, and you might need to, again, readjust yourself on that. So we solve for x, add 4, and we get 6 is equal to x. Excuse me. So that's the algebra portion of this in most cases. Let's take one quick look at the proof. Whoops. One quick look at the proof style of this. So sometimes you have to use the properties of parallelograms and proofs, and sometimes you might have more than one parallelogram in play. So in this case, we're given that both these shapes, the top and bottom of the shape, are parallelograms. So they're both parallelograms. That's my given. And I want to prove that AB is equal to EX. So usually what you're going to do in these cases when you want to prove that two segments are equal is you're going to use the transitive property or the substitution property after you've made a chain or a link. So the idea here is to link AB to EX. So you want to find a common theme that both of them have, which in this case is this middle line right here, CD. Because if you notice, CD is in both. CD is a connecting segment. It connects the top parallelogram to the bottom parallelogram, and those are your key things in proofs usually. So when you're trying to prove something, look for anything like a side or an angle, or in this case here a segment, which is also a side here, that's connecting the shapes that you're working with. So I'm going to try to see, okay, how do AB, EX, and CD relate to each other? Well, I know that AB and CD are congruent because they're opposite sides of a parallelogram. So I know that AB is congruent to CD because they're opposite sides of a parallelogram are congruent. Now that's also true for EX and CD. So EX is congruent to CD, because they're also opposite sides of a parallelogram are congruent. So I can put them in the same section since they use the same reasoning. Well, if AB is equal to CD and EX is equal to CD, that means AB has to be equal or congruent to EX. Why? Well, because of transitive, or if you want to, you can say substitution. Substitution. I know my handwriting is not that good because I'm getting used to this mouse here. Even though I've used it before, it's just feeling a little off today. So you'll have to excuse the worse than normal handwriting. And again, the way you can visualize this step is to think about it like a chain. So AB leads to CD, and CD leads to EX. So if AB and CD are connected, and CD and EX are connected, that means that these two have to be connected to each other, because this is basically the middleman. So if CD was, say, 7 meters, that means AB is the same as CD, so it also has to be 7 meters. And EX is the same as CD, so it also has to be 7 meters, which means that AB and EX are going to be the same as well. That's what transitive and substitution is you have a link here, and then you connect the ends of that chain. So that's usually how proofs go when you want to prove two segments, or even in some cases two angles are congruent, is you set up a chain here. So you start with one segment or angle, you lead it to the next, you lead it to the next, and you lead it to the next, however many times you need to go, and then at the end, you connect the two ends of your chain by transitive or substitution, however you want to call it. But that's the purpose of transitive and substitution step, is to connect the ends of a chain of congruencies that you've been building up. And that's one way people prove two things are congruent, is they use this transitive property after setting up this chain. So that's one of the things that's a technique that we'll fall back on a few times when we're doing proofs with parallelograms. That's it for this video. Again, mainly focus on the algebra bit here, making sure you know kind of how we did, how we did these here. Knowing the properties here is going to be important because that's going to be the key to your algebra stuff. So knowing when things are congruent, when they're supplementary, and that sort of thing. And then just kind of understanding the basics of the proofs, because we'll get into more of those later on. Hopefully you enjoyed this video. Have a good day, night, or afternoon.